looking at the horizontal translation of the sine and cosine curves. So this is section 10.3. For all the graphs that we have investigated so far, the period has always started at x equals 0. What will happen to these graphs if some constant c is subtracted from x? So in blue right now, I'm going to put my typical sine function here. All right? So there's my y equals sine of x. Okay? But now I want to consider this equation here. Y equals the sine of x minus pi. So I know my amplitude comes from that a value. So amplitude is the absolute value of a there. So the absolute value of 1 is 1. And we know that 1 should be right in front of the word sine. Okay, the period length. Well, I'm going to show you what this graph looks like. It looks like this. So in red, I have just graphed y equals the sine of x minus pi. So we look to see what really happened from my blue graph to go to my red graph. So as c is greater than 0, the basic sine graph shifts right. Okay, now the period length. We talked about the period length in our normal sine function being 2 pi, because that's how long the graph is. It started at 0, it ended at 2 pi. But now here, we are starting at pi, ending at 3 pi. So the difference between this point and this point is still 2 pi. Okay. So now if I look at the one below, I'm going to graph our basic cosine curve in blue. Okay, so in blue is our basic cosine curve. Now we're going to consider y equals the cosine of x plus pi. Okay, my amplitude. I know amplitude is the number in front of the word cosine or sine. Okay, that's my a value. So the absolute value of that value, absolute value of 1, is 1. Now I'm going to draw this cosine curve now for y equals the cosine of x plus pi. Some of you might have an idea of what this is going to look like from thinking about the graph above. But this graph is going to be looking like this. So we see as c is less than 0, the basic cosine graph shifts left. Okay, and if we want to think about this period length here, we know it starts at negative pi, ends at pi. So we're thinking, how long is this graph? Okay, so from negative pi to pi, it's a length still of 2 pi. So the period length of this graph is 2 pi, just like our regular cosine function, except this one was shifted left. All right, let's take a look at the next page here. The process of moving a graph left or right is called horizontal translation. The distance that the graph is moved is called a phase shift, that we will sometimes abbreviate as a PS. Now, the procedure for graphing sine and cosine curves with the phase shift is listed in these steps that you see here, which is also on your sheet. Okay? If you have any concerns or if you're not sure where to go, you can reference these steps. I'm going to, however, walk you through these steps for 2 examples on the next page. Okay. Previously, I've been doing the original graph in blue and the final graph in red. Right now, I am just doing the final graph in red, so there's only going to be one curve on this graph. All right, first thing I want to identify is some of my values here. So I want to figure out my A value. My A value is the number in front of the word sign, so it's 4. My B value is the number in between the word sign and the X, so it's going to be 1/2. So that's what we've done so far on these. All right, so amplitude is the absolute value of A. So the absolute value of 4 is 4. The period length is 2 pi divided by B. So right now we have 2 pi divided by 1/2. This is the same thing as 2 pi times 1/2, which gives the period length to be 4 pi. My quartile length I need in 4 equal pieces. So I take 4 pi divided by 4. So the quartile length is pi. Now my phase shift is something new. To find my phase shift, I'm actually going to take what's in parentheses and set it equal to 0 to solve for x. Okay, so I'm going to take what's in parentheses here and set that equal to 0. So for my phase shift, I'm going to say 1/2 x plus pi over 2 equal to 0. Now, I want to probably get rid of those 2's. So if we remember back to some of our rational functions, we can multiply 2 to everything here. When I multiply 2 to everything here, 1/2 times 2 is just 1. So I have 1x. 2 times pi over 2 is just pi. And 0 times 2 is still 0. So I just cleared the fractions. So for my phase shift here, I have x plus pi equals 0. I want to solve for x. So I'm going to subtract pi from both sides, and I get x equals negative pi. All right, my phase shift here is a negative pi. All right, so on the left of these points, I'm going to write the 5 critical points for sine function. Intercept, max, intercept, min, intercept. So intercept, max, intercept, min, and my 5th one's intercept. Now I'm going to think about these x coordinates, where I have always started with 0 for this first critical point for my x coordinate. My phase shift is now going to become the x coordinate of my first point. Okay, so that phase shift, negative pi, that means negative pi is the x coordinate of my first critical point. So now to get the rest of the x coordinates here, okay, here, 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 and here. Remember, I take whatever this is and add the quartile length. So here I'm going to take negative pi plus pi to get 0. Then 0 plus pi to get pi. Then pi plus pi to get 2 pi. And 2 pi plus pi to get 3 pi. So I have all my x coordinates. So I want to do a spot check real quick and think. The length of a graph that starts at negative pi and ends at 3 pi goes a length of 4 pi. Perfect. That is what my period length is here. So now I need to figure out the y coordinates. Well, we talked about earlier, if they are intercepts, my y coordinate is going to be 0. The amplitude talks about the highest point on the graph. My maximum value, because my amplitude is 4, my maximum value is going to be 4. And my minimum value is going to be negative 4. So now I have all my points that I want to graph on here. I'm going to go negative pi and 0. 0 and 4. Pi and 0. 2 pi and negative 4. And 3 pi and 0. So I have 5 critical points that I'm going to connect. There we go. Okay, sketch of y equals 4 times the sine of 1/2 x plus pi over 2. Okay, so now we're going to take a look at our cosine curve. So my cosine curve is y equals 2 times the cosine of 2x minus pi over 2. The first thing I want to do, my a value is 2. My b value is 2. And actually, when we're talking about the phase shift, we've now been introduced to the c value. The c value is this thing here. Okay? All right. Here we go. Amplitude. Absolute value of a. Absolute value of 2 is 2. Period length is 2 pi divided by b. So 2 pi divided by 2. The period length is pi. Now the quartile length, whatever the period length is, I divide by 4, and I get the quartile to be pi over 4. The phase shift is our new add. Okay, my phase shift. I'm going to take whatever is in parentheses and set it equal to 0. So for my phase shift, I'm going to take 2x minus pi over 2 equals 0. And I'm now going to solve for x. So I'm going to add pi over 2 to both sides. And now I need to divide by 2. And I'm going to get, well, we know pi over 2 divided by 2 over 1 is the same thing as pi over 2 times 1 over 2. So we'll get a phase shift of pi over 4. Okay, so that means my graph starts at pi over 4. And I know for my cosine, okay, my first point is the max. Then I go intercept, minimum, intercept, max. All right, if I have pi over 4, I now take this pi over 4 that I got from my phase shift and add another pi over 4. Pi over 4 plus pi over 4, 2 pi over 4, which simplifies to pi over 2. Pi over 2 plus pi over 4 becomes 3 pi over 2. Oh, excuse me, 3 pi over 4. That's a 4 there. Fourth critical point, 3 pi over 4 plus pi over 4 is pi. Plus another pi over 4 gives me 5 pi over 4. All right, for my y-coordinates, I know intercepts are all 0. My maximum value comes from my amplitude, which is 2. Likewise, my minimum is negative 2. So I'm going to graph pi over 4 and 2. Pi over 2 and 0. 3 pi over 4 and negative 2. Pi and 0. And 5 pi over 4 and 2. So we had to add some points in between there to get our cosine curve. I'm just going to clean this up a little bit here. So we know that that's a 3 pi over 4. Okay. So there's your cosine curve for y equals 2 times the cosine of 2x minus pi over 2.